Good morning, and welcome to today's webcast, Elevate Your Pre-Vesting Process with AI. Before we begin, I'm going to play a brief housekeeping video.
Welcome, and thank you for viewing our webcast series. Before we begin, please keep the following in mind. You can customize how you view our presentation and interact with the presenter. For better viewing, close all other applications and turn up your speaker volume. You can adjust window size and placement or enter full screen mode using the controls at the top right of the window or dragging the bottom right-hand corner to resize. At the bottom of your screen, you'll see a series of icons that relate to a different aspect of our session. You can download a PDF of today's slides from the Slide Deck and Handouts widget. You can ask questions by typing in the Q&A window and clicking Submit. We'll do our best to answer all questions or follow up via email. If you experience technical difficulty, refresh your browser by hitting the F5 key. This presentation is not legal, investment, or accounting advice. We encourage you to seek the counsel of a professional service provider to apply this content to your specific circumstances.
I'm pleased to introduce today's presenters for Moss Adams, Tim Oakes, partner, and Austin Olfers, senior data scientist. And with that, I will pass it over to Tim to get us started.
Thanks, Talia. Yes, my name is Tim Oakes. I'm a partner here at Moss Adams. I've been working with equity compensation systems for over 25 years and helping companies just process their equity better. Austin?
Yep, and I'm Austin Olfers. I've been with Moss Adams a little over 3 years, applying AI and software best practices to the equity world. Thanks, Tim.
Thank you, Austin. So Moss Adams, you probably already know who we are, but we are a CPA firm that has both tax accounting and as well as consulting, and we're in the consulting group. We're a full service firm providing a lot of services for a bunch of different clients. Austin and I concentrate a lot on system development, and we do a lot of stuff with equity in particular. For today, we're continuing our discussions about artificial intelligence and how artificial intelligence can help you in your day-to-day life around your equity plans. So first, we're going to talk a little bit about today's landscape, talking about how pre-vest audits look. We're going to drill into some pain points. We're going to talk about a machine learning solution that can help the existing pre-vest processing. We'll go through how to figure out benefits and ROI to help sell a solution to your leadership. And then we'll take a little bit of time to talk about where we're going next with AI. So first, today's landscape. This should be very familiar to anyone who's dealing with restricted stock and equity plans. So, you have a vesting timeline. Prior to vesting, there's stuff coming in from HR, there's payroll changes, there's equity changes, there's unusual tax events. And then you get to the day of vesting where you collect the FMV, you actually process the vest, and then you communicate the deposit of shares or sale or other things with the broker. And then you get into the settlement where things are sent off to payroll, you release the shares, and then you fix any last minute errors that you can find. And then post-vest, you resolve any remaining errors. And sometimes an employee calls and says, hey, why did I get taxed for this? Or this doesn't look right. And so companies always are trying to move those errors, fix them ahead of time so that the employees don't see that. And the way that companies do that is with a pre-vest checklist. And so the companies over time build this up based on the errors they see. And for example, you can say, well, if all the releases have taxes calculated on them, do all the US releases have a federal, Medicare, and Social Security taxes included? What's going on with the terminated employees? And so this is common, and this is a best practice for companies. And I'm sure that all of you have your checklist. We're going to dive into a polling question before we continue on about just setting the groundwork for this presentation. So here's the polling question. Go ahead and answer. Does your company perform a pre-vest process to catch potential share and tax problems? Yes, every time. Yes, but only for large vests. No, but we perform post-vest audits. No. Or no, unsure or not applicable. So I see we're getting some answers in already. We'll just give it a little bit of time. I think what's interesting is, different companies, some companies have vest events throughout the month. Some companies have them on specific days of the month. And so each company has a little bit of difference here. We have about half of the responses in, so I'll just give it a little bit longer. Okay, just a couple seconds more. It's slowing down, and so we'll go ahead and move on. Let's see what the answers are. Yes, every time, 31%, which I'm glad, that's good. Yes, only for large vest cycles. Yeah, and that's also very common. If you have onesie twosies that happen throughout the month, and then you just deal with your large ones, that makes sense. And then I'm sure that the other unsure, not applicable, the 36% are people who probably are just listening in and might not have this in their world right now. But interesting about the no, 9% don't perform, but they do perform a post-vest, and then 13% say no altogether. So let's talk a little bit about, I talked a little bit about how different companies have different experiences, and this will look different. So for instance, a company that has recently IPO'd, recently gone public, a lot of times we see them using Excel. They came from one environment, a very different environment, and now they're working with this. The knowledge base that they're using is kind of a best guess of potential errors. Oh, we understand that California SDI has to be calculated, so we're going to go check that first. And the error volume can be pretty significant when you're first working out the process, and you have to learn where the problems are and kind of come up with your process. So the mid-cap companies, still a lot of times they're using Excel, but they've usually formalized a checklist procedure. They've learned some lessons, learned some hard lessons, and can usually keep their process pretty clean. Now, they still run into some errors and things that they have to fix afterwards. Large enterprise companies, sometimes they have a dedicated or custom software that actually helps them with the pre-vest checklist. Sometimes it's all embedded into an automation system. And so then they have very few or no errors. Let's talk about some of the pain points with this. So with the pre-vest checklist, it usually requires manual effort. And anytime you have a person involved, you have a possibility of human error. Also, there's the whole thing about who's doing it, and if they go out on vacation, is the person who's going to pick it up know where all the things are. It also, as it is a manual effort, as the company grows, it could be difficult to scale the process. And they usually only find errors that have actually been seen before and have been caught. And so those are the ones they put into their checklist. And of course, the knowledge is just with the stock plan professionals. And so, payroll or other people might not have it. And then a little graph over here showing, great, as the company grows, the cost of errors grow, but you capture a lot of it with your pre-vest checklist. But there could be some that are not detected. They're new things. You've gone into a new country, or you have a new acquisition that has people set up with the different taxes that you don't realize. Those errors can end up being very costly. So even a single error can cost, administrative time. You could be fixing tax withholdings. You might have to repurchase shares if too many shares were sold, or if the shares should have been sold and they weren't. You can also run into IRS fines for not withholding the taxes. And if it is not caught until at the end of the year, you might end up in a situation where you're doing W-2Cs. And so that is not only irritating, but also can add to your overall cost and administrative time. So we're going to go to our next polling question. So how mature is your stock administration process right now around this pre-vest? Do you think it's well established and well oiled? Very few errors occur? Do you think that it's efficient, but there's some room for improvement? It's very new and needs some severe assistance, or other, unsure, or not applicable? So we'll just give a little bit of time for people to answer.
And I'll jump in here real quick, Tim, and say that, from our last polling question, I know 36% of you might not necessarily fall under the criteria of needing to perform a pre-vest checklist to some extent. And I still think you guys will really find some of the machine learning implementations pretty interesting as we go on to the kind of the following slides after we're done with this polling question here. And we'll kind of explain how this kind of same technology, although we are in this instance tailoring it towards the pre-vest and the equity world, it's something that can be applied outside of the equity world as well. So just wanted to kind of highlight that as well.
Very good, Austin. Yes. Okay, so give it just a couple more seconds. It's kind of slowed down. I think we've probably got all the answers we're going to get, and so we'll move on. Thank you so much. Let's see what the results say. Incredibly well established and well oiled, 30%. Great. Efficient, but room for improvement. Sometimes we get error. Yep. New or needs severe assistance. Nobody. Great. And then other, unsure, or not applicable, 50%. Totally makes sense. Thank you so much for answering the question. We're going to move on, and Austin, I'm going to hand it over to you.
Great. Thank you, Tim. Yeah, so we've now gone through and kind of established why this process is relevant and some of the pain points in them and why some of those errors that can pop up can be costly. So now we're going to kind of transition a little bit over to what the solution is and how machine learning can play a role into that. So the process itself, we can use clustering algorithms in machine learning to identify previously unseen and potentially erroneous transactions and flag them for review. These outliers or anomalies can be then reviewed by the team and then potentially added as business rules back to that pre-vest checklist to prevent those to prevent those errors from going forward. So let's dive into that a little bit. So what's the data actually look like? Some of you may be familiar with what we're looking at here. This is pre-release data, which can be extracted from platforms. If any of you are familiar with Morgan Stanley's Equity Edge Online or Schwab's EquiView, both equity management platforms for companies. And so the information that resides within these kind of data files are all of the upcoming vests for employees, potentially the amount of shares that are getting released, the value of the shares, where their mobility is from, and kind of their wages, all the kind of information and tax information that goes into knowing, how much to withhold for taxes or how much the employee will ultimately get at the end of the day. So this is the kind of the data that we start with, and we are going to be performing the machine learning analysis on. So what does clustering actually look like? I wanted to kind of have a preemptive slide here to kind of illustrate kind of what's actually going on when we say clustering. So if you look at kind of this visualization here, you can kind of see data points on the left and then a series of groupings or clusters on the right. Now, in this instance for pre-release data, you can kind of think of each one of these data points or each one of these circles as being one specific vest that will occur for an employee. And so you can kind of imagine as groupings kind of emerge, you can kind of see that similar types of data will be attributed to different clusters of information. So we can kind of use this in order to kind of determine, what groupings of information is relevant to the pre-release. Where do employee data look similar to others, and so that's kind of how that is beneficial.
And Austin, and Austin, I think that a lot of people that are probably listening to this, they probably do something like this themselves when they get a pre-release file from their vendor. They might sort it and they might filter it. They might say, hey, I'm going to go look at all the California people. And so that's a cluster. Or they might want to look at everyone who's in France and see what's going on with the people in France or in UK. And so that's a cluster. But Austin, I believe that the clustering we're doing, this is a very simplified view of it, just trying to give the concept of it. But when you turn it over to the machine learning, it's actually pretty complex, right?
That's correct. Yeah. Right now we're looking at an example that has 2 dimensions or 2 columns, an X and Y axis. But when we're doing this on a data set that might have a 50 columns, 100 columns, we can still perform this clustering on that. It's hard to visually represent that. And so, yes, you're right, Tim. We do kind of simplify this just to kind of make this more clear in this context. So kind of now that we've got our clusters identified, what this then allows us to do is kind of see what resides outside of these clusters. And so in this next graphic, you can kind of see there's one central cluster that exists in the middle there, and then there's a bunch of what we call outliers or anomalies, which are essentially data points, or in this case, VEST records that we don't see as residing within that main cluster or group. So if we say, there's probably some, in this instance, maybe some tax information incorrect about one of these data points, or some mobility, something was wrong, we can kind of get to kind of use this to see where do our outliers exist within our data set. And so that's really what we're doing here. So that's kind of the benefit there. So now if we actually kind of dive into a little bit more of a complex situation with some redacted equity data, we can see kind of this is more along the lines of what we would expect a typical company's best data to kind of look like when we do this kind of grouping and clustering analysis. We kind of typically see clusters in terms of jurisdiction or locations, just because we obviously know that similar jurisdictions will lead to similar tax information across them. And so we can typically see like, oh, if there's a bunch of if there's a grouping in Berlin, Germany, or if there's a grouping in Finland, for example, all of the tax information and the tax rates and everything are going to be similar across all of those employee records. And so that's kind of why we get to the point of this kind of, it ends up kind of grouping in terms of location. And obviously you can get really narrow in terms of, some local jurisdictions will have taxes too, right? So in that instance, that might be a slightly different cluster than maybe something in a different local jurisdiction. But kind of the thing to take away from this is that what we have witnessed in the past is that this data ends up being clustered by location. And that's kind of the important thing to pull away.
And Austin, just quickly on this, I love this slide, although it does look a little bit like I'm looking at microbes in a microscope, but the thing is that the X and Y axis are really just the algorithm has given some kind of value to the data. You can, as humans, we can pick out the patterns. We can see those curved lines and we can see all the dots that are coming together. You can't see it very well right here, but there are some colors where the algorithm says, hey, even though this one exists amongst some other ones, this one doesn't look like the rest. It's kind of like back to Sesame Street. One of these things doesn't look like the other. And that's kind of what's going on here.
Exactly. Yeah. So all of the blue dots that you see here are all of the records that we're essentially saying these likely are just part of the broad population and don't contain error. But if you've maybe been able to see, there's some other colors on this graph as well. We've got, and there's that legend in the right side there that kind of speaks to that. What we're going to do is kind of narrow down and drill into one exact cluster here. We're going to look at the Berlin example because it has one of those outliers amongst them. And so I want to really kind of show what that actually looks like and why that was pulled out. So if we go in, zoom into that, we can see here that this is, again, this is just a zoomed in view. So this is just that cluster that we just had highlighted in that red box. And if I zoom in just a little bit more so we can kind of read what's on these tooltips a little bit better, we can see that for each of these data points is one specific vest. And we can see that all the blue dots all have, they're in slightly different locations, but in general, they all look pretty similar, and all of them have a state code assigned. In this case, BEs for Berlin. And so what we've noticed in the one record that was red, or in this instance, identified as an outlier or anomaly, we can see that state code is actually missing. And so this could be from an upstream data error in a different HR system. This could be, there's a whole bunch of different reasons why the state code might be missing on this specific piece of data. But essentially what the algorithm has told us is that this specific record is an anomaly because it's missing a state code. And this could lead to an error down the line with, potentially miscalculating taxes or something else. But the fact that it's basically residing within this cluster itself means that it probably is a Berlin, Germany record. It's probably just that the state was for some reason not assigned and or missing. So yeah, that's kind of what and this will kind of tie into our next slide, which is what we've kind of seen from clients as being really important, which is the explainability portion of this. We've really kind of, what our clients have requested is that, it's not necessarily just good enough to say if something is an error or not an error. What's really important in a business context is to understand why something was an error. And so one of the things that we can attribute to this is kind of different explanations. And so here I'll kind of go through what some of the output of this analysis kind of looks like. So in this instance, the first column that we've got appended is kind of the cluster ID. So again, anything that was in that blue would have its own kind of saying non-anomaly versus anything else would be an anomaly. And in that case, it'd be like all of the non-zero cluster IDs would be considered anomalies. Our next column that we've got is the total magnitude, which is kind of a way to identify or sort by which records that were identified are most likely to be errors. So the higher that magnitude is, the more likely that there was an error that occurred within that anomaly. And that's just kind of calculated by kind of seeing the difference between like those records and adjacent records and seeing like, okay, how many differences are there amongst this one record? So that's kind of the benefit of having a total magnitude there, is the ability to sort. And then in addition to that, we also have some explanations in terms of the columns. So in the instance of that first record at the top there, we can see the explain one column has, it says that the taxable gain 11 was one column that contributed a lot to the reason why this anomaly was detected. So the explain one, explain two, so on and so forth, allows you to kind of really drill in and say, okay, why do these things pop out as anomalies? We can then drill in and say, okay, let's take a look at the taxable gain 11 on this one record. And maybe for some reason that the gain wasn't calculated. I don't know. So it's something you have to investigate, but it essentially takes, instead of having to sort through 25,000, 30,000, however many records you're working with, it allows you to kind of really have a narrow focus and say, okay, it's really worth drilling into these 30 records instead of having to drill into 25,000 or 30,000 records.
And Austin, I think that back to the example, so I do believe a lot of stock administrators are already taking a pre-vest report and they're slicing and dicing, they're pivoting on it and things like that. But, this algorithm, I'm amazed every time we see this, because this algorithm, can zero in on these particular things that we might overlook, when we're zeroing in on California SDI or saying, okay, I need to make sure that the UK has the right taxes. We might have missed that, the taxable gain on this one looks a little different than everyone else that's right in this area. And so to me, I'm just always amazed. And I love this view that the algorithm can pop back out and say, hey, taxable gain on this one is a pretty big problem. And so take a look at it.
Yep, exactly. Great. So now, how does this actually get incorporated back into your process, right? We all have established that a pre-vest checklist is something that's pretty common in the equity landscape. So how does this actually go and help that process? So one example is that you could go through and then say, okay, now that we've identified that, at least for that Berlin example, that we want to make sure for going forward, we want to make sure that all eligible participants have a state code assigned. And obviously some countries don't necessarily have state codes, but that could be some criteria of that business rule. So that's one way to kind of go about this is, take the learnings from this analysis and revise the actual checklist so that we're including more of the potential errors that could occur. The second way that you can go about this is kind of having this as like your kind of final check. You're saying, okay, we still want to make sure we're adding all the business rules that are relevant to the potential errors that were found. But what's really powerful is being able to then still be able to find the potential errors that happen in the future, because it's not like a one and done type of game where that once you've identified one type of error, that error will never happen again. That's great, but it's possible that like new mobility locations come up, or maybe your company is now operating in a different country. So, there's a bunch of different things that could come up as that progresses. So just kind of having this as a final check can be a really good way at just making sure that you're being more forward looking for potential errors that could occur.
Yeah, and Austin, one thing is this methodology needs a large data set to really work well, right? And so it like I said before, some companies are it's nice they have a single date in the month when they have all their vests happening, but some companies have one-off vests for whatever reasons, because of the on-hire way they do their on-hire grants or leaves or something like that. And if you have a small sample set, this process doesn't have as much to cluster on and find the outliers, because everything looks like an outlier, everything looks like its own cluster. And so actually finding the errors in the big things and adding to your pre-vest checklist is a great way to do something like that. But yeah, this works best with a large data set, right?
Mm-hmm. Yeah, and large can be variable, right? So if you have, it could be 1,000 might be big enough. It could be 100 might be big enough. It depends on depends on your exact scenario. So yeah, that's something we could, work through and identify. But so with that, I'll pass it back over to Tim to kind of talk a little bit more about the benefits and potential ROI.
Thank you, Austin. Yeah, so of course the benefits are, by doing this, you can find them early and do the corrective action before, having an actual financial impact. It's actually low cost and minimal effort to implement. And so, you give us the pre-vest file and we run it through the process and we spit out some errors that are just like that list we saw. And so then you can take a look at it and say, oh yeah, this is or not, whatever. Of course, it's easily to implement on an existing business process. Maybe you already have something. And what I really love is it's scalable, because I think that all of us have our processes that work really well right now, but businesses grow and you run into more problems the bigger you get. Now, of course, this is just one example of outliers, and I think pre-vest is a great place to use it because you have a short time frame to really get it right, and you usually have a large set of data. But you could do it in acquisitions or your annual grant or divestitures or conversions moving to another platform. And so there are a lot of places where you can use something like this, and the effort is pretty low. So of course, if you needed to go and sell this to your leadership, basically the costs to figure out the return on investment, what is the cost of running the outlier analysis? And it's pretty reasonable. And then, think about all the potential cost of errors that you have. Like we said, just even one error could end up being a $25,000 cost for that error. And so then you subtract out, the cost from the potential errors, and there's your potential return on investment. And so it might make a lot of sense to do something like this. And with this one, I think I'll take this one. I'll give you the next one, Austin.
Okay.
So in one example, what happened was there was an HRIS data input error that caused the state to be coded wrong on employees during an employee's relocation. And the shares were sold for the wrong state's tax rate. And so it looked good, the state was there, but someone would have had to have looked at it and find that it's the wrong state and the wrong taxes for the state. And it took a lot of time to correct. And then it took about $30,000 to repurchase the shares that were sold in order to do that. But we actually use machine learning in this situation, and we were able to find that problem. And so we could have saved them that $30,000 when we did this, if we did this audit for them. So Austin, I'll let you take the next thing.
Sure. Yeah. So one other example that we've seen from a client is, if we're taking one of their large vests as an example, we were able to run this machine learning analysis beforehand. And of in this instance, 22,000 records that came out or were going to be included on an upcoming vest, 30 outliers were identified. And we went back and said, okay, here's what we believe to be potential errors. And they went through and reviewed them. And after their review, they told us that 28 of the actual 30 were errors that could have caused some type of financial impact, which was honestly, to me, being from a data science world, was kind of absurdly high. I was kind of shocked at how effective it was, to be honest. But all to say that, that doing this beforehand allowed them to implement business rules in order to catch those errors from happening again, and again, saving hundreds of thousands of dollars to make sure those errors didn't actually execute and act upon. So with that, we're going to go and navigate to our final polling question, which is, would your company benefit from incorporating this into your existing process? Yes, I could have used this yesterday. Yes, but we would need some time. Maybe, still unclear in where it fits in. No, I don't see a use, and other and not applicable. A lot of this was, trying how can we convey a lot of this information in a way that's consumable for maybe a non-technical person? So hopefully we are able to do that. But if not, please let us know, and we need to revise kind of our methodology and how we're doing this. But yeah.
Yeah, not even non-technical. I mean, some of the stuff that you were talking about, along with some of the other people, and it's like you were going over my head. When you're talking about, okay, is this, underneath the curve, or not, or what is the p-value or something like that? I forget exactly what the terms were. And so, yeah, to me, this makes a whole lot of sense. I relate it back to, doing it manually in Excel spreadsheet, but the computer just does it so much better to go and find all those pieces. We're still getting some more answers in, so I was going to let filling in a little time to let people answer the poll. But we're slowing down now.
Awesome. All right, I'll go ahead and move on to the results page. Cool. So we've got, yes, I could have used this yesterday at 5.5%. Yes, need some time, understandable. Maybe still unclear where it fits in. Totally get it. This is not, a totally easy thing to wrap your head around. And if you have questions, feel free to put them in and we'll try and answer them. And if not during this, after this, to try and clear anything up. No, I don't see a use. Totally fair. Other non-applicable, 27%. So thank you for the responses there. Cool. So this is going to kind of take us a little bit into some of our future pathways. So we've kind of discovered kind of what this means from an individual process perspective. But once you've kind of done this clustering analysis several times, what allows you to do is then kind of have a historical bank to kind of use what's called supervised machine learning. And supervised machine learning is really just kind of a similar way of identifying outliers, but instead of trying to find, a certain percentage of a certain data set as things to review, we're trying to use historical knowledge in order to predict on future records. So in this case, if we've got 4 historical, and this is a small example, but if we've got 4 examples to kind of base our vesting model off of, we might have 4 that 2 with error and 2 without an error. Using AI and machine learning, we can then train a model to kind of identify what the correlations are between the vests and say, oh, maybe it is the state code that's missing, that's causing this, or maybe it's something else. We can go through and say that the model is able to generate those correlations and essentially identify, potentially erroneous transactions. And so what this allows you to do is then, with new transactions that haven't been run through this model yet, we can then say, okay, let's compare what we have for these new transactions and run a model through it. And then with that, it'll kind of output us in whether it's an error or a not error. So kind of, again, it's a similar vein where we're still trying to identify outliers and trying to reduce the amount of errors that can come across. But what this really allows you to do is have a higher accuracy model. And so this is just something that's only really possible once you've kind of done this process a handful of times.
So Austin, with that is, to me, there's 2 things here. Again, we're having the large data set to do the process, but we also have to tell it whether the things were errors or not, which, after you've done the vest, you can definitely tell the machine whether it is or not. But what's really nice about this is, previously when we were talking about, you have to have a certain number of transactions, a certain amount of data before you can really use this process. With this one, you don't have to have that, because that quantity of data is already there in the historical stuff. And so, this could do the smaller vests where you just have a couple on the day, and it could accurately predict whether there's an error or not. And so that's what's lovely about this.
Yeah, thank you, Tim. Cool. Well, I'll hand it back over to you to kind of talk a little bit about some other of the equity services that we have as well.
Yeah. So we are wrapping this up. I'm sure we'll have some other webcasts in the future about AI. Some of the other things that we do help people around, reviewing systems and helping with regular processing, and then some advisory services. And so we do more than just the AI. If you have some needs, reach out to us and let us know. I'm really glad you joined us for this, and I hope you found value in it. We do have a little bit of time. If you had a question, you could throw it into the question box. Otherwise, here is our contact information. You can go ahead and send us an email, and we will respond as needed. But we didn't get any questions as we went through this, and I don't see any popping in. And so we're going to go ahead and wrap this up. Thank you so much for joining us. And Austin, did you have any final thoughts?
Nothing for me, but I'll just pass it over to Talia to round us out.
Excellent. Thank you all.
Awesome. Thank you, Tim and Austin, for a great presentation today. If we didn't have time to answer your questions, we will do our best to follow up with you after the webcast. Here's a link to an online survey where you can provide feedback for today's presentation. Please take a moment to complete this survey, as your feedback is very important to us. Thank you for joining us. We hope you'll join us again next time.